This is Joseph Ryan Bernicki with Professor Osbay's Aero Design class, and today we're going to be going through the Ansys project. We're going to be modeling the wind tunnel with an inlet velocity of about 1.34, low speed flow through a wind tunnel, and yeah, so we're going to go ahead and hop into it. So let's go ahead and move me out of the way here. Now we're just going to build the geometry in Ansys. We could build it in whatever we wanted, really, as long as we can save it as the right file and import it into Ansys later. If this was a more complex geometry, I would consider building in SolidWorks or something like that, but it's pretty simple, so we're not going to worry about it. For most of this geometry part, I'm probably, if I can figure out how to do it, I'm probably just going to speed up through while we're building this stuff, because it's really just tedious. A lot of it's just putting in measurements, making sure that everything is right in the way that is wanted. So our test section needs to be 6 inches in height. So, and we're in inches, right? Ooh, units. Okay, yeah, we're in inches. Okay, cool. So, yeah, so it's 6 inches in height. We went ahead and did that. We know that's going to be 12 inches long. So let's just go ahead and horizontal, or we can just general it, because I don't feel like clicking 2 places. So general, H3, 12 inches, boom. Now we are going to draw. I want everything to be aligned with the origin, because that's how I did it on the previous times, and that's how I'm going to do it this time. You could have it lined up with the corner or wherever you want to line it up with. It doesn't matter. As long as you take note of it, midpoint, here we go. As long as you take note of it so that when it comes down to like doing your plots and stuff, you know where to do your X values at. We're trying to get important information. Okay, so yeah, that one's all set up. That is our test section. So now we can go ahead and just do more constraints. Let's go ahead and equal length. Boom, shift, click. We're gonna need to draw another construction point. Click, and again, there's probably, I'm not the best with Ansys. There's probably way more efficient ways that you could probably build this. I am a beginner at Ansys. Beginner, and I'm proud. So boom, there we go. Okay, and basically we're just going to go through and we're going to do that same thing throughout the settling chamber, contraction chamber. We already got the test section, the diffuser, and we're just going to keep dimensioning everything out. So I'm going to go through and do it, because if I sit here and try to talk through the whole video while I'm building it, it's going to take forever. So now we have our geometry all built up, and we have everything ready to go. So we can go ahead and we need to create a surface from the sketch. So right here, we're going to click right here. Why is it giving me a problem? Oh, sketch 1. There we go. There we go. Sweet. And now we got this. Generate. Sweet. All right. Let's go ahead and get this going. So let's save that. Okay, but now we have our geometry. We have. Cool. So I had to reset there, but either way, this is where we left off. This is the surface that we finally ended up with. So we're going to go ahead and exit out of this, because we don't need this anymore. We already made it. The geometry's in there. Now we're going to go into meshing everything. just double click it. Double click and it works. Okay, cool. So now we are going to go into generating the mesh. So we're going to generate mesh. And then it should give us a new, here we go, mesh. Sweet. So we're going to go ahead and change the method. We already actually have it in triangles for some reason, but yeah, cool. So all triangle method, that's what we're going to use. Automatic method, I don't know why that's in there. We're going to delete that and get rid of it because we don't need it anymore. Okay, so element size, we're changing that. We want to change. So let's go into sizing. Element size, we're going to apply it onto this geometry. The size, we're going to do 5 times 10 to the negative 3. Okay, well, Ansys doesn't 0.005. No. Okay. Oh, that's what I need to do. 0.005. Note to self. Click the geometry before trying to edit settings. That'll help a lot. Okay, sweet. So let's go ahead and let's update it with the settings, and it should be a much finer mesh for our simulation, which will be much better for us. Nifty. Look at that. Now we got a ton of triangles. All right. So now that we have the mesh, I know we can go ahead and select edges, and let's go ahead and name these edges. So I can click this right here, and I know the shortcut is N, and then here we go, selection name. So this is going to be our velocity inlet. So now apply to selected geometry. Yeah, that's fine. Cool. Now let's do it again. Oh no. Okay, good. Click that. Shortcut is N. We're going to do pressure outlet. That is fine. Now we're going to control. We're going to control click all these surfaces. Boom, we're gonna let go of control. Now we're gonna hit N. Now we're gonna name this wind tunnel walls. Apply selected geometry. We're gonna go ahead and click the velocity inlet, pressure outlet, the wind tunnel walls. Ooh, but see, that's not correct. That actually needs to be adjusted because it's not 9 edges. So 2, 3, 4, 5, 6, 7, 8. Apply. Deselect that and then select these. There we go. Finally. Oh my God. Okay, there we go. Apply. Thank you. 8 edges. 8 edges is our wind tunnel wall. Pressure outlet. Velocity inlet. And then I believe also we need a interior, if I recall from, because I did my last one yesterday. So face, yeah, let's do that. That sounds great to me. N, cool. Wind tunnel interior. Apply to select geometry. Cool. Now we got all of our name selection. Our mesh is good. Our mesh is fine enough. We did it through the all triangle methods. We are good to go. So let's just save it. Now let's exit out of this because we don't need this anymore. And now that our mesh is good, let's go ahead and update it. Make sure it's happy. Need the green check marks. showing me messages. It's loading. I'm just gonna let the computer think. Yeah, we're good. Okay. Double click setup. Now we go into, we're gonna be able to do everything else for the rest of the simulation in this next one. We don't have to keep switching back and forth after this. And again, like I was saying, you can do geometry and meshing in completely separate apps or separate programs if you want. We just did it in here because it's simple, and I need to show it throughout. I didn't want to be hopping from program to program while doing this recording. So we're going to do it in double precision. If I learned anything from modeling methods, that's good. And display mesh after reading. This sounds good. Solve processes. From what I saw, people ran 2. I know it depends on how many cores you have on your processor. But I'm just going to run 2. It's going to be just fine for what we're doing for the moment, and it'll work. So everything's booting up. Okay, cool. That's what I like to see. Aeros. Now, energy. This is one of the things. This energy equation needs to be on. K omega. We don't want that. We want K epsilon. And then we're also going to want enhanced wall treatment on pressure gradient and thermal effects. Thermal effects, we don't really deal with that. It's just the intro I watched did that, and that's why I based my other states on, like the 10 hertz and the 30 hertz. So I'm just going to do it for this one as well. We're going to stay consistent. Okay, so that should be good to go. So, oh, that's wrong. Nope, that's not wrong. Psych myself out. Okay, so that's all we need in the models. Materials, we want to make sure we're running air. Yeah, that's fine. Okay. Cell boundary zones, fluid, wind tunnel interior. Ansys, you're smart. You're on top of it. That's exactly what we needed. Boundary conditions, inlet, velocity inlet, awesome. Outlet, pressure outlet, awesome. Wall, wind tunnel walls, awesome. Internal, interior wind tunnel. It already got everything all set up for us. Now, again, I don't recall, normally we could go through and we could actually tell Ansys what we want to be what. Now, I don't know if it's because I pre-named it before, or maybe it's because it's in the same project as the other wind tunnels I already did that already pre-did this for us. But either way, it's done. It's nice. It's handy, so we don't have to go through that. We do want to make sure that our velocity inlet, though, yeah. So our magnitude, this is how we're going to actually set up our wind tunnel. So for 50 hertz, I already solved it, 1.34. Again, this is really low speed, 1.34 meters per second. 1.34 meters per second. I got more digits. I'll put it in. Why not? Cool. And that's going to be everything that we're going to do here. So we're going to apply that. And if I recall, we do not need to do anything with the pressure. Nope. Yeah, we're just going to leave this as is, because I believe that's exactly what we did to our previous ones as well. Stationary wall. Yeah, our wind tunnel is not moving on us, thankfully. That would be worrisome. Velocity, 1.34, 1.34147. Viscosity, 1.4, 1.225. Okay, so it's using air. Compute from velocity inlet. Yeah, okay, that's why I said 1, because, okay, that makes sense. Okay, cool. So now that that is all set up, we are going to head into methods. No, actually, we don't need to mess with methods. We're not going to mess with methods right now. We're just going to go into, we're going to initialize it. Hybrid initialization. Initialize. Hopefully this works. Okay. We shall see. Now let's go ahead and do our calculations. Go into run calculations. Number iterations. I'm just going to pump it out to 150. Just because I'm pretty sure it'll converge. And cool. So here we go. It's calculated. This can take some time depending on your computer and depending on your setups. Like if your computer's obviously loaded up and you're running a bunch of stuff, it's going to run slower. But just wait, be patient. It'll come through. Wow, that's a little longer than... Okay. Okay, well, let's see what it did. So now we can actually go ahead and start putting out the information that was required of us. First things first is going to be contours. So we're going to go ahead and do pressure, static pressure. Let's go ahead and just name it, keep everything good. Static pressure contour, if I can spell. It's right in front of me. Static pressure contour. Okay, cool. So look at that. Contour line, we don't need that. Draw mesh, we don't need that. Boundary values, we do want that. Okay, cool. So let's get this lined up so we can actually look at this a little bit. Sweet. So, there we go. That's nice. Cool. And you should be able to see it too. Sweet. Okay, so this makes sense. A reduction in pressure in the test chamber where velocity is the highest. That's looking good. I remember on my last couple of models, especially when doing, we're just gonna go ahead and pump out the rest of these contours as well. So we need also the absolute, or not absolute, total pressure contour. Save and display. Cool. Boom, there we go. Whoa, this is different. Okay, so on my previous simulations, I did notice, so see how this tail of pressure, how it's like going down almost? On my other models, it was going up. Now, I don't know. I'm interested in that. I don't fully understand why it's doing that. But it's just something that I've noticed that I need more time to think about. So we got total pressure, we got static pressure, we need dynamic pressure. So let's go ahead and pressure, dynamic pressure contour, save and display. Dynamic pressure is increasing in the test chamber as static pressure decreases. That's cool. And again, the tail, look at how it goes down to the bottom section of the diffuser, which makes sense again, but it's gonna continue throughout all of our contours. And then let's go ahead and do a velocity contour as well. Contour velocity, name everything to keep it nice. Velocity contour. Yeah, that's it. Save and display. Cool. Yep. High velocity in the test section. That's exactly what we would expect. That looks good to me. Cool. So the contours are really easy, as you can see. It's just a matter of clicking, basically clicking what you want and what you want to show and putting it out on the screen. Now, plots are a little more difficult. When we were doing the geometry, I was speaking on creating the origin however you wanted. We made our origin of the geometry at the center of the test section. However, you could have done it wherever. But when you're doing your XY plots, you need to account for it's based off your origin and your geometry. So if you put your origin in the middle, like we did, we have our origin right here in the test section. So when I'm doing my X and Y plot, I need to go certain amount to which let's figure that out. Let's figure out what our amount is right now, because we're gonna need that. So I'll show you. So to the left of the test section, we're right in the middle of the test section, our origin. Our test section is 12 long total. We know it's right in the middle. We got 6 inches on one side. We have our contraction chamber, and we have the settling chamber for our total length. And that'll be our negative value on the x-axis that we're going to be doing our xy plot to. So we got the 6 inches from the test section. We got the 24 inches in length from the contraction chamber. And then we got a 15, I don't remember if it's a 22, if I dare not. It's 15 inches in length is the settling chamber for a total of 45. So negative 45 inches in the x direction is what we're going to be doing. Oh, wait, actually, we need to draw a line first. I forgot about this part. So, new surface, line rake. So now, here we go. So now we want these points to go from, what did I say, negative 45? We're still in inches. Oh, we're in meters. That's fine. Let's convert. Let's get our good old friend Google. Inches to meters. So we had, what was it, 45 inches, I think it was, right? Cool, 45, 1.143 meters. So we are negative 1.143 meters to left, 1.143 meters to left, and then we are going to be so if we have 6 inches, let's go to the right. So we got 6 inches of the text section plus the diffuser. That's all it is. And the diffuser was 42 inches, if I recall. Correct, 42 inches. So 6 inches plus 42, 48. 48, 1.2192. 1.2192 meters. Perfect. Create. Cool. So now that we have this line here, we can actually go through and we can get a normal plot of let's do our velocity, just because we already know how the velocity is going to act. We're going to start low velocity, increase, and then we're going to decrease again on the diffuser. So if we're right and our plots are right and how everything is the way we want it to, we should see a nice hump with the velocity. So we're doing the y-axis functions, velocity, velocity magnitude, direction vector, that's fine. And we can do write to file. I'm not going to do that right now because I'm going to do more of that when I'm actually going through. I'm finishing up the report right now. So I'm going to just mess with that later. And that should be, line 5, that's what we want. So we're going to save and we're going to plot, and look at that, beautiful. Nice hump, just as we would expect. Again, XY plot 1, we don't want to do that. We want velocity plot. Let's do that. Cool, save plot. Now, let's go ahead and build another one. The cool thing is, now that we've already established that line, it's real easy from this point on. So we already got velocity. Let's do pressure, static pressure, line 5. Name our plot, static pressure plot. We're going to save and plot it, and an exact inverse just about of our velocity. So now we're going to do the dynamic pressure plot. My girlfriend scurried across the room to evade the webcam. So we'll see if that if she showed up or not. So let's go ahead. All right, so let's finish the static pressure plot. Save that, exit that, new plot. So we got static pressure, we got velocity. We're going to go into dynamic pressure. Dynamic pressure plots. Line 5, just like before. Save and plot. And again, very similar, just an inverse. Cool, so velocity, static, dynamic. What are we missing? Total. I'm missing total pressure. So pressure, total pressure, plot. Boom. And then line 5. Cool. Save. Now that we have all of our XY plots, we have all of our contours. We have everything. We have all the information that we need. Now the next step would be to go through and we could actually export the information from the XY plots. Like, another thing, you can't just double click, you gotta actually go through and hit display. So we're gonna go through, we're going to take all of this information, we're gonna compile it into the report. We're going to do it for the 10 hertz, the 30 hertz, and the 50 hertz like we just showed in this video. And that should be everything. So thank you very much. Again, Joseph Ryan Bernicki for Osbay's Aero Design class. Have a good day.